Okay, in this video I'm going to show you a simple minimization problem called an assignment problem for optimization, and you should be able to reason through what the optimal solution is just by looking at the data. However, we're going to work through how you do it in Solver in Excel, because in real life companies will use exactly the same steps. They'll just have a lot more drivers and a lot more routes. So let's start off here with just looking at the problem. What we've got here are driver 1, driver 2, and driver 3. So this could be like Peter, Paul, and Mary, for example. And then you've got two routes, route 1 and route 2. And you can see that driver 1 wants $60 to drive route 1, and driver 1 wants $60 to drive route 1 and $65 to do route 2. Similarly, driver 2 wants $75 to do route 1 and wants $70 to do route 2. And then the third driver wants 80 and 82 respectively. Now if you look at this, it makes sense because this is like school buses where all the bus drivers are out at the same time, so you can only assign a driver to one route, but it makes sense to put driver 1 on route 1 because of these three prices. That's just the cheapest. And then it would be nice to put driver 1 also on route 2, but each driver can only be assigned to one route because, again, the buses all run at the same time, so they can't be in two places at one time. So the second lowest value is driver 2 assigned to route 2. That's $70. Driver 3 has bid themselves out of the running because their prices are too high. So how do we set up this problem now? Well, the first thing we have to do is we have to we understand what the decision variables are, and that is if there's a 1 in this cell, it means we assign driver 1 to route 1. If there's a 0, it means driver 1 is not assigned to route 2. Okay, so when we're done, we'll have 0s and 1s in here representing the number of routes to which each one of these drivers are assigned, and the constraint will just be the sum of all that. And I can take that and copy it down. But each driver must be assigned no more than one route, less than or equal to. So we can not assign a driver to any route, or we can assign them to one route, and that's all that we're allowed to do because of that constraint. The number of drivers assigned to a route is the sum of this column here, and this is just the sum of this column. So sum of all this. Because we have to have every route covered, that means it's equal to 1. The constraint is that the number of drivers assigned to route 1 must be exactly equal to 1. The total number of drivers assigned to route 2 must be exactly equal to 1. Okay, now the total cost is what we're trying to minimize. And to do the minimum cost, all we have to do is use the sum product function. The sum product function says take all these values, comma, and multiply them by all these values here as they match. So it's saying take 60 and multiply it by whatever value is here, 0 or 1. Take 65 and multiply it by whatever value is here, 0 or 1. Do that, 75 times the value here, 70 times the value right here, 80 times the value right here, and 82 times the value there. All of those pairs of multiplications you want to add up to come up with your total cost. And that's going to be 0 because we don't have any values in here. Okay? So let's now do what the Solver solution will do. Now remember, to do this problem you have to have Solver installed. You see, if I go to Data and then I go over here to Solver, then I can do my minimization problem. If you haven't yet got Solver into your Excel, you can go here to File and all the way down to the far left to Options, and then go to Add-ins right here, and up will come this screen here. In the inactive application add-ins, it should say Solver add-in. I've already added mine, so it moved it to the active application add-ins, but you would click on Solver add-in, which would be in here, and then after you have selected it, you click on Go, and that should then move it up into the active application add-ins. Click on OK after you press the Go button, and then go to Data and just make sure Solver is there. With Solver there, what we want to do is fill in this minimization optimization problems parameters. So the first thing we want to do is, what's the objective? Well, it's the gray bar box right here. the total cost of assigning drivers to routes. By changing these values, which are the decision variables, subject to these constraints. This value must be less than or equal to that value. Click on OK. This value should be less than or equal to this value. This value should be less than or equal to that value. So now we've got these three constraints. Now we have to do this one here. This one, whoops, I've got that wrong. I inadvertently set the objective to D15. It should be set to D19. Sorry. I forgot to press the add button. I need to go to add. And this needs to be exactly equal to that right there. Okay. And add one more. This value here, the total number of drivers assigned to Route 2, must be exactly equal to this value here, which is 1. Okay, and so I've got 3 less than or equal to constraints and 2 equal to constraints. We accept this checkbox here and set this to the simplex method, and then click on solve. We found a solution, click on OK, and it's what we predicted just by looking at the data. Driver 1 will be assigned to Route 1, and Driver 2 will not be assigned to Route 1. Driver 2 will be assigned to Route 2, but not to Route 1. And Driver 3 doesn't get an assignment because they were too expensive. So the total cost of assigning drivers to routes would be $130 a day. And that's the how you would do a minimization problem in Microsoft Excel using Solver as an optimization minimization problem called an assignment problem.